In the last couple videos, we've been doing constructions, and one thing that I think is really cool about these constructions is that when we're doing something like bisecting an angle, we've got those steps, and I can tell you that this line segment that we made bisected the angle. And I can tell you that the reason I know that is because some really, really old guy 2,500 years ago came up with that set of instructions, and whatever, we'll just take his word for it. But really, the fact of the matter is that we can prove to ourselves and to each other that these things are true. And so what we're going to start transitioning towards is talking about those proofs. We need a bunch of different tools in order to get that done. And so what we're going to do is we're going to review something we did in a previous video, which was talking about triangle congruence. And in this video, we're going to talk about the most important consequence of knowing that two triangles are congruent. So let's take a look at my document camera. All right, so here I've got a triangle right here, ABC, and I constructed A prime, B prime, C prime by using the normal set of rules for copying a triangle. We saw the videos for that. So I opened up my compass to AC. I measured this line segment to be the same distance. I measured from A to B, made this arc over here, measured from B to C, and drew this arc over here. And that way I was able to find B prime. And so what we were able to do there is, by virtue of what we were doing with the compasses, I know that those two line segments are congruent to each other. I know that these two line segments are congruent to each other. And I know that these two line segments are congruent to each other. And because of that, and because of the SSS theorem that we talked about in a previous video, we know that that's enough information to know that these two triangles are congruent. It's a little hard to see, but I just laid one on top of the other through the pieces of paper, just by doing a translation and a little bit of a rotation there. But here's the important thing, and here's the really interesting thing, that if I look at angle A, or the intersection of the yellow and blue angle sides, and I look at the intersection of A prime, the intersection of the yellow and blue sides, these two angles are going to be the same measure. The same thing is going to happen at B prime, and the same thing is going to happen at C prime. So in a way, you can think that triangles have 6 different measurements associated with them. We have the lengths of 3 sides, and we have the degree measure of 3 angles. Okay, 3 sides and 3 angles make 6 pieces of information. We only needed the 3 sides in order to prove that the triangles were congruent. And based on that, we automatically know that the other 3 pieces must also be congruent. And so we can conclude that the angles are congruent even without measuring the angles, just from having to known that the sides are congruent. And the idea here has a special name in geometry because it's such a central idea. The idea is that corresponding parts of congruent triangles are congruent. So let's just take those words and translate them into what we just saw in the diagram. So this angle A and angle A prime are corresponding angles between these two congruent triangles. All right, so if I move the triangle over like this, A is going to line up with A prime. So this angle is going to line up with this angle. That's what makes them corresponding parts. Just like this pink side corresponds to this pink side over here. So those are examples of corresponding parts of congruent triangles. And what I know is, since the triangles are the same size and shape, those individual parts must also be the same size and shape. So those corresponding parts are congruent. So that's what it means when I say corresponding parts of congruent triangles are congruent. And that is something that we are going to be writing so often over the course of this year that we usually wind up writing just the acronym CPCTC. All right, so CPCTC, corresponding parts of congruent triangles are congruent, is one of the key reasons that we want to show that two triangles are congruent, because it lets me say something about the angles of those two triangles without measuring the angles. All I needed to know was to measure the sides to know that the triangles are the same size and shape, to know that those triangles are congruent. And because the triangles are congruent, I can immediately say things about the angles. So we're going to see in the next video how we can use this information to do interesting proofs.